Welcome to you all for this online lecture video. So today we are going to see the topic of shift register. So this is the topic which will come in the digital principles and computer organization course. So myself, Dr. Sudhakar, let's move on to our topic. So shift registers. So about the introduction about registers, okay, and shift registers. Let me see one by one the types of the shift registers. So here there are four types of shift registers: SISO, SIPO, PISO, PIPO. Okay. And introduction. So before moving the shift registers, we should know what is registers. So register is a collection of flip-flops and it's taken as an entity. So and there's a question is what is flip-flop? Again, the question comes. So the flip-flop is a memory element. It's a one-bit storage memory element. So there's a one-bit storage element. There is if you're grouping together, we call this as a registers. So these registers will be helpful for holding informations or processing informations, okay, for doing one particular operations, okay. So this will help to successful completion of one particular operations. By doing the process of the information within the registers, we need how we can access the data or how we can access the information in the flip-flops, that is called as registers. So that we move on to the next one is called as shift registers. We are moving the data from one flip-flop to another flip-flop. So here that we seen in the shift registers. So I'm just reading the topic definition. So shift register is a collection of flip-flops taken as an entity, and the function doing some functions. It's hold some informations in the systems, and it is available to the logical elements during the computation process. Okay, so that one we can able to compute the process or functions. Each combination of the informations is known as the content of the register. So the shift register is capable of moving or accessing the informations upon the occurrence of a clock signal. So the clock signals is whether you are giving synchronous or asynchronous. Okay, so but based on the occurrence of the clock signal, we can able to access the information in the shift registers. And how we can access the information, whether we are using unidirectional or bidirectional. So the unidirectional represents we are accessing the information. We already told that it is a collection of flip-flops. We are arranging one by one after another. Okay, so some group of flip-flops are there. How we can access the flip-flops further from the left to right or right to left. So they are using any one thing. So if we obey only one direction, we call it as a direction. So that whole circuit, that whole register is it capable of accessing both sides, we call it as bidirectional. So at a single time, at a single time, we can use only one direction, but we can able to do that in bidirectional. Okay, if needed. So this is the shift registers, and so there is in two basic ways we are to how to access the information, how to moving the informations, how to moving the data within the shift registers. There is an two possible ways, whether we are giving serially manner or in parallel manner. In serial manner, it involves the data or symbols as availability based off of information in a time sequences. So one after another, we are passing the data to the shift registers in serial manner. Means we can use the time sequences at a time one data. That's like number one data. So for example, first minute one data, the second minute the second data. Like that, we are shifting the data through serial manner. In parallel manner, we can be able to handle the data and we are shifting the data at a simultaneously. Okay, it requires many lines or symbols being transferred, but we can handling simultaneously. Okay, so based on these ways, basic ways of serial and parallel accessing of shift registers, we classification as four types: serially input, serially output. We are giving the input as serial manner, we are taking the output as serial manner. Likewise, so here the other three are serial input, parallel output, shift register. Parallel input, parallel output, shift register. Parallel input, serial output, shift registers. So this is the four types of shift registers. Let me see one by one. First one is a serial in, serial out. This is unidirectional shift register. We are giving the input as serial manner. So I'm note down here serial data input. Okay, and this is the serial data output. So here I'm using the four flip-flops is a D flip-flop, output as Q bar and clock signal. Here using edge triggering clock pulses. I'm using clock simultaneously clock applying clock pulses here. And for D flip-flop I'm using. So for example, if you're giving the input 1101, because I'm using the four flip-flops here, one. If I'm giving the one for single clock, first clock pulses, it is stored in the first flip flop, and the second clock pulse it moves from the the first one to the second one. For third clock pulses, it moves from the second one to third one. For fourth clock pulses, it moves from third flip flop to the fourth flip flop, and finally the last pulses, clock pulses, the data will be out as a at the receiver side. Okay, so serial in and serial out. For better understanding, I like to show one time as a sequences here. So here a sample is a 4-bit shift registers I'm using here. So the data input is 1011000004. 8 data input is here, but I'm using 4-bit shift register like what we seen here it here. So first one, second one, third one, fourth one, 4 shift register, output 1, output 2, output 3, output 4. For time 0, there's first 0th clock pulses, there is in all are empty 0000. For first clock pulses, I'm giving the MSB here 1 1. For first clock pulse I am applying the input as 1. For second clock pulses I am applying the second input as 0. 0 I am fetching here. So for that at the same time the first output will be passed to the second flip flop. Okay, this one will be passed to the second flip flop, and then this is the 0 for new data I am entering into the first flip flop. For third clock pulses I'm giving the data here is 1 1 I'm giving, and sequentially it will move to the first flip flop to the second, second to third. And the fourth clock pulses, I'm applying again the one. So one, and this will be transferred to the next one. And fifth clock pulses, again I'm giving us 0 here. Here fifth bit is 0, it must be a 0. So I'm applying 0. And now what happened? This one will become out as serial data. Okay, serial data as an output. For fifth clock pulses, I'm getting the first data. Okay, first bit of data of my data input as an output, first bit, MSB bit. And for the sixth clock pulses, again the second bit I will receive as 0. For the seventh clock pulses I'm getting as third bit as 1. And fourth, eighth clock pulses I'm getting it as again the one will come. This one will be as an output. So I'm receiving is after the eighth clock pulses I'm getting the four data. So 1011 will come. Okay, and the ninth clock pulse, 10th clock pulse, 11th clock pulse, and 12th clock pulse, and 13th clock pulse I will receive all the output. Okay, 10110000 will I will receive it. Okay, so this is the process happened in the serial in, serial out. You can able to understand now, I can hope it. And this is the small animation, you can able to see that. So first you can see the first it's a clear 1001 is your data input. Okay, and shift and shift will come automatically, the data will come. So based on the clock pulse, one clock pulse, again shift, again shift, again shift, the output will come 1001. Likewise I'm trying to explaining that one output. Okay, this one. Okay. Yes, I hope you understand. And now it's a serial in, parallel out. This is unidirection left to right I'm using. Same very simple process. The same I'm giving the data fetched as a data as 1011, but upon the fifth clock pulses I'm getting the output as parallel. Okay, because 4 clock up to I need to have a 5 clock pulses to fetch all my data serially. Am I right? Yes. And after the sixth clock pulse, if you put in the sixth clock pulses, I will get the output QA, QB, QC, QD parallel. Okay, so this is the serial in, parallel out, and parallel in and parallel out unidirectional shift register. So this is comes under, so parallel in, parallel out, and here serial in, parallel out also we can use it. Here I'm using serial data, serial output, serial data in, serial data out, parallel data out, parallel data in. Okay, so all together we can use it here. Okay, so here I'm using the one more conditional loop cases, load or shift. Okay, so here the main purpose of taking this one is we can give the parallel input is very easy. Parallel input, and we can take the output as parallel. Okay, so but we're using the circuit. If the circuit helps, okay, we are can able to apply serial data also. I already told that the previous versions we are giving the serial data, taking the parallel data output. So serially, how we can give, if you give the output input as parallel, how we can get the output as a serial one? That is the main thing the question will arise. So for that we can able to do all those things in a single point. It is unidirectional shift register. So this is the operation. This is the operation of whether this circuit will act as a load the data into the flip-flop or shift the data to the other flip-flop. This is the main thing. So if it is enable, if it is 0, what happened? It will act as a load. If it is 1, it will act as a shift. Okay. And the clock pulses, synchronous clock pulses, see that. And one of the input here, the serial data input, there is a 2 AND gate on OR gate. So one of the input is serial data input for one AND gate. The another input should be as a load, and the second AND gate, one of the input is a shift, and the another input as input of data input. Okay, so this one we can able to use load, and this one we can able this. So this is the load, and we can use as the shift. So at that time it will act as a 0. This will be one will be enabled at a time. This upon from the 2 AND gate, one will be enabled, another will be as 0, not it. It is a disable condition. So this is the logic behind. If it is logic, if it is 0, this will be enabled means it will be give to the shift. If it is enabled, it will act as a load to the flip flop, and it can keep an as a store. Okay, and based on the operation, by enabling it, okay, this one, see that for every AND gate, for both AND gates, everything will be connected. Load shift. For third flip flop, it's a load shift. For fourth flip flop, it is a load shift. One of the input for AND gate is connected as a load. Another AND gate in one of the input is connected as a shift, and another input should be the data is serial in, another input is here parallel data in. Okay, so by enabling the load and the shift, we can do multiple operation in a single shift register. Okay, so this is the structure we are created, or not we okay, that defined in this book is probably it's a parallel input and serial output is most complicated. So for that, it is very helpful for parallel data input and serial data as an output. Yes, this is the four registers we summarized. Okay, but here we discussed serial input, serial output, parallel input, parallel output, serial input, parallel input, serial output. Okay, and let me see the, and we can soon the next topic is soon. Okay, thank you.